Let's take a look at the solution to this problem that we set up in the previous video. We've got a toy car. It's got a gravitational potential energy for the whole car, which includes the body of the car and its four wheels. And when it gets to the bottom of the ramp, it's going to have kinetic energy for the whole car because everything's moving forward at the same velocity. And it's going to have rotational kinetic energy just for the four wheels. So first off, let's go ahead and establish that the rotational inertia for each wheel, if it's a standard wheel, we're going to treat it on a toy car as a solid disk. So it's going to be 1/2 mass times radius squared. And if we go and start plugging things in, we'll have mass of car times g times h is equal to 1/2 mass of car times v squared plus, let's see here, the 1/2 and that disappears to make a 2. So we'd have 2 times the rotational inertia of the wheels, 1/2 m times r squared, multiplied by v over r, the quantity squared. So like before, our r squareds are going to end up canceling out here, because that becomes squared, r squared cancels, and the 2 and the 1/2 cancel, and let's see what we get. We'll have m car times g times h equals 1/2 m car v squared plus, sorry, this is m wheel, got to be careful there. Almost neglected that w there, because in the rotational inertia, the mass over there in that equation is the mass of just the wheels, not the whole car. So that would be mass of the wheels times v squared. And if we go ahead and start simplifying stuff, we'd have to pull the v squared out. So we'd 1/2 mass of car plus mass of wheels, which that's not supposed to be an equal, it's supposed to be a parentheses, equals m car times g times h. And at this point, it really just becomes a bunch of algebra. It's going to be kind of ugly, to be completely honest. But if we try to solve it out, move this whole term underneath the m car gh and then square root it, we should have m car times g times h divided by 1/2 m car plus mass of the wheels. And that should get us to the solution for the problem.